Okay, this is taking us through 14.4, the normal curve or normal distribution and the bell curve here. So one thing that we talked about in class was this is the normal distribution curve. And we're talking about the area under the curve, and it represents 100% of the data. Oh, and I believe that was on video 1. The few things that I really want to point out before we head into the next section is that this is 68.3% of the data that lies 1 standard deviation above the mean and 1 standard deviation below the mean. So you'll see us going, down by 1 standard deviation, the width, and then above by 1 standard deviation, whatever that standard deviation happens to be. In the next category, we move 2 standard deviations out away from the mean. So moving 2 standard deviations out above and below gets us 95.5% of the data in that region that we're talking out to 2 standard deviations. Finally, the last one that we're going to talk about is 99.7% of the data is captured when we are 3 standard deviations away from the mean. So we're way out on these narrow tails and capturing the data, almost all of the data, 99.7% of the data. The area under the curve is 100%. So there is still some data out here at these very tails, okay? We went through this on the other one. What I would like to do is get into, that was day 1 homework. And then this is what we did on day 2, 14.4. So people that missed Friday, here is what you missed. I'm going to have you print off some extra examples because I changed the examples that I had included on the original note packet. Jot this down. I altered the formula slightly. You will now see that there is a bar above the X here to represent the mean. This will be some value that we can calculate. And then this t-value is coming off of the chart right down here. And this is our standard deviation, which could be calculated to be some value. So it becomes t times standard deviation. So if I were 2 standard deviations away from the mean, this t would be 2, and then whatever the standard deviation amount, maybe this was a 5, maybe this was 20, 25, 30, where my standard deviation was a 5. So that is how that formula is going to be used. And this TP chart represents, this is actually a percent if I move the decimal point, so 8%, 15.9%, and so on. It's just the P is represented in decimal value, representing, could also represent percent. And then T talks about standard deviations. If you take a look at 1, you'll notice that at 1, it comes in at 0.683. 68.3% of the data lies 1 standard deviation above or below the mean, just like we had pointed out when I was talking earlier. When we're at 2, we're at 95.5% of the data. When we're at 3, 99.7% of the data. And finally, when we get out at 4 standard deviations, way out on these tails, 4 standard deviations below the mean here, then we're at 99.99% of the data. So practically all the data is contained in plus or minus 4 standard deviations. So here was the problem I want to take you through. Marguerite determined that the average woman in her math class is 63 inches tall. All the women in her class are between 53 and 73 inches tall. So first thing I wanted us to do is determine what is the standard deviation. It's not given in the information directly, but we can calculate it. So the first thing I noticed is it talked about the average is 63. So my mean, my X bar, is 63. The next thing I read was there's some data endpoints, 53 and 73. All the women in her class are between 53 and 73. I'm going to extend my graph so that I can get out here and talk about x minus 4 standard deviations, and I'm going to extend it above, and so I can talk about x plus 4 standard deviations. Because remember on that PT chart that we were just talking about, when we were down at 4 standard deviations, we were at 99.99% of the data, practically all the data. So we're going to use 4 standard deviations here to help us figure this out. So this would be 73, and this would be a 53 down here. I noticed that this has a distance of 10, and it's broken up into 1, 2, 3, 4 standard deviations. So if I take 73 minus 63, the area above the curve has a distance of 10 units divided by 4 standard deviations, I can calculate out what each standard deviation must be. So 10 divided by 4, that tells me my standard deviation is 2.5 units. Okay, so I'm going to erase this. If I were to sketch my graph at this point, I could say this is 65.5, add my 2.5 standard deviations, and I would be at, let's see, 68, 70.5, and then up to that 73. Likewise, we could go down below 60.5, subtract 2.5, and we'd be at 57.5, subtract 2.5, and I'm at 55. Oops, something didn't quite work out there. And then I should be at 53. So it looks like my mistake is right here. 57, 55.5, and then subtract 2.5, and I'm at 53. What percent of the women in the class would be between 60 and 66 inches tall? Well, 60 and 66 inches tall don't happen to lie on the nicest values. 60 and 66. So kind of this area in here. What space would that contain? So here's my 60, here's my 66. And my question is, what percent of the women lie between this? We're going to use this formula right here to help us do this problem. So I'm going to put in, I want to know 66 is my high point. The mean was 63. I'm going to add to 63 a t-value that gets me to 66. So if I subtract 63, just solving, I'm going to pick up 3 equals t times 2.5. Divide by 2.5, and t will be equal to 3 divided by 2.5. So grab your calculator and quickly calculate that out. Sorry, I didn't have it done. 3 divided by 2.5 is 1.2. I get a t-value of 1 and 1.2 standard deviations. If I back up and look at the t-chart, so grab your t-chart, 1.2 correlates with 77% of the data. So this, the answer to it, is 77% of the data. T equals 1.2 gives a p-value of 77%. Lastly, what is the probability that a woman chosen at random in her class is between 70.5 and 73 inches tall? So they're looking for this area out here. I'm going to give you a new sketch on that. That was between 3 and 4 standard deviations. So 3 standard deviations above the mean. So x bar plus 3 standard deviations, and then this one was plus 4 standard deviations, got us to 70.5 and the 73. And they want to know what's the probability, or basically what percentage lies in that region. So here's what we should do. think how I want to proceed on this. Okay, I just paused it for a moment. Here's what I wanted to draw out. So we want to calculate the percent that sits in this region. I drew two pictures, one representing 3 standard deviations, one representing 4 standard deviations above the mean. And then I went to my P and T chart and I looked up 3 standard deviations is 99.7% of the data. That would be symmetric over the mean. But I only want the upper half up in here to be accounted for. So I divided by 2 and I came up with the fact that this is 49.85% of the data in this region right in here. Then I did the same thing. I went back to that PT chart and I looked up 4 standard deviations and I knew it was 99.99%. And I showed that 4 standard deviations was 99.99%. I'm going to divide that by 2 so that I can talk about just the upper half of this region, and that is 49.95. If I take 49.995, 4 standard deviations, and subtract 49.85%, I am left with 0.145%, and that is what this particular value will be. So very, very, very small, but we know that there's very little data up in that area, or very few data pieces sitting up there. This is the last one that we're going to do. A set of 500 values is normally distributed with a mean of 24 and a standard deviation of 2. What percent of the data is in the interval 22 to 26? Well, let's just basically sketch out our normal distribution here. Mean is 24, increasing with a standard deviation of 2. So that makes these 26, 28, 30, 22, 20, and 18. The first question asks, what percent of the data is in the interval 22 through 26? So right in this bandwidth, notice how this is 1 standard deviation above and 1 standard deviation below. That would be 60, oh shoot, I'm losing it, 68.7% of the data, I do believe. 68.3% of the data. I didn't think that sounded right. 68.3% of the data. Next question, what percent of the data is in the interval 20.5 to 27.5? So 20.5 doesn't click right on that, unfortunately, and 27.5 doesn't click right on that. So we're going to have to do some t-values on this. All right, so my endpoint is 20.5, and that's going to be equal to a mean of 24. Subtract off a t-value times the standard deviation of 2, all fitting into that particular formula. Endpoint of the interval, the mean of the interval, and the standard deviation. Okay, calculating this, I'm going to subtract 24. That's going to get me negative 3.5 is equal to negative t times 2, so negative 2 times t. Divide this by 2, and I get a value, divide by negative 2, 1.75. Let's double check, but I think we're going to see the same t-value above. 27.5, our upper limit, is equal to 24, the mean, added with, because this time I'm going to add to get bigger, the standard deviation of 2 times a t-value. Once again, subtract 24. Yep, we're going to see same values coming out of this. Here's 3.5 equals 2t, divide by 2. T will turn out to be 1.75. So I have a t-value of 1.75. Back to the PT chart, 1.75 is right here, and that would be 91.1%. 91.1%. We just need to grab one of those values. Find the interval about the mean that includes 50% of the data. So C is structured a little bit differently. I want 50% of the data. I'm going to clear this screen. 24, 26, 28, 22, 20, you get the idea. I want 50% of the data. So 50% of the data is a p-value. What is the corresponding t-value of that? So let's go to our table, look up for 50%. I'm going to hit clear on this too. 50%, about closest right here, that has a t-value of 0.7. So t is 0.7. Now I can find the interval or find endpoints on top and bottom using this formula. So my endpoint will be x bar, which is 24, the mean, added and subtracted 0.7, 0.7 times our standard deviation, which was 2 right there. 24 plus or minus 1.4, multiplying those two together. That gives me an upper value of 24 plus 1.4, sorry about that. That's going to give us 25.5 on the upper limit. And then I could go 24 minus the 1.4. It'd be nice if I'd line things up. And that's going to give us 22.6. So our interval that includes 50% of the data is 22.6, carrying up to 25.4. All off of the TP chart using that formula that was there. I think we're going to call it quits. This is probably getting long.